Okay, so let's begin with topic 2B, atomic structure. So we are going to be going through the MCQs, selected MCQs, and then the structured questions, again selected questions. Through this, I hope you are revising the content and also how to apply the concept. All right. So we are going to go to question 1 for the MCQs now. So question 1 looks like this. If you have done it, great. If you have not done it, do it now. All right. I'm just going to give you 1 minute, and now I'm going to set up a poll for those who are in the lesson. You will choose which option is correct. Okay. Now it's anonymous. So please feel free to choose, but think first before choosing. All right. So let me launch the poll now. Do you think A, B, C, or D is correct for question number 1? So let me give you 1 minute to do it. Okay, so far I've had 5 votes already. So there are 10 students, I think, in this group. How about the rest? I have 6 students only. How about the rest? Okay, 7 students have voted. How about the rest? Okay, 9 students now. Okay, 10 students. Okay, so now I shall show everyone the results. All right, now you can see the results. All right, now the answer is C. Now, this one question already requires 4 steps of thinking because there's W, X, Y, Z. This is very typical for pure chem MCQ. There are 4 steps of thinking per MCQ. This will not pass as a combined science as MCQ because too many steps of thinking. All right. Now, the idea is the difference between atoms and ions. So first, okay, for those who chose A, that means you did not understand the atom and how to use the nucleon number. So for those who chose A, you need to know nucleon number is P plus N. Protons and neutrons added together form the nucleon number. If the nucleon number is 39 and there are 19 protons, that means this W is 39 minus 19 equals to 20. Okay, so A cannot be the answer, B cannot be the answer because W must be 20. The atom of potassium has 20 neutrons because the nucleon number is 39, the proton number is 19. So to find neutron, we take 39 minus 19. Do not say it's carelessness. Okay, if you chose A and you know who you are, if you chose A, please ensure you read through what is nucleon number and proton number again. Now, some of you chose D. If you chose D, that means you have mistaken how ions work. You need to know positive ion means it has lost electron. You lose valence electrons and become a positive cation. So K plus must have lost 1 valence electron. So at first it had 19 electrons, now it has 18. All right, so X is 18, sorry. X is 18. So this must be 18 because it lost 1 electron. On the other hand, a negative ion, an anion, means it has gained electrons. So S2 minus is doubly negative. If it's double negative, means it gained 2 valence electrons. Therefore, Z must be 2 more than a proton. So this is 18 as well. So the answer is C. If you didn't choose C, that means you did not understand ions, meaning revise chapter 3, atomic structure. Okay, at this juncture, any questions about this one MCQ? You can see from the MCQ, okay, it relates to your misconceptions. So those who chose A, you need to revise nucleon and proton numbers. Those who chose D, that means you didn't understand how the ions work. Go and revise ions, also in chapter 3. Okay, so now I'm going to end the poll. All right, so now we're going to do the next question. Okay, the next question we will do is actually question 3. Now, for question 3, before we start, I would like you to know that these are the old ways of naming the group. Now, we don't call it group I anymore. We call it group 13. We don't call it group 0. We call it group 18. So can you please edit the group numbers first? We are on question 3 of the MCQ. Again, I'm going to get you to vote in a short while on question 3. Okay? So now if you have corrected the groups, I hope you have had a think about it. Let's launch the poll. Let's start. So again, I have 10 students. Only 5 students have voted. How about the rest? Okay, 7 students have voted. 8 students have voted. 2 more. Okay, 10 students have voted. Now everyone shall see the results. Okay, so it's quite split. It's quite split. Only D, no one chose it. All right, so the answer is C. Now, this question should look familiar to you. This is very similar to your WA1 question, which many of you also got it wrong. So this is where you start revising as you read the notes. When I say notes, I don't just mean notes, but also look through your past work, be it the work assignments, be it, the extra questions, be it your WA 1, 2, and 3. Now this is WA1. And the strategy to doing this actually is really simple. Whenever you are given proton numbers, when you can count the number of protons, always use this to identify the element first. You can identify an element based on the proton number because elements are arranged in order of proton numbers. So 13 protons means this is aluminium. Al, aluminium, right? Just go to the periodic table, find element number 13. That's aluminum. Once you get aluminium, I'm sure you can work out its period 3 and group 13. This is what a strong student will do immediately. Now, the other options, of course, are there to trick you, right? Because you are told this is an ion. Many students may not realize this because they thought, oh, it's 2-8. 2-8 means 10 electrons. Is it neon? Is it a noble gas? The answer is no. It's an ion, right? That means it has either lost or gained valence electrons to form 2-8, a stable, fully filled outermost shell. So the 2-8 is not the original electronic configuration of the element. The element has clearly lost or gained electrons to achieve 2-8. So don't be tricked by that. Okay? So how did it become 2-8? Originally, it had 13 electrons. Because it had 13 protons, originally it must also have 13 electrons. How did it become 2-8, which only 10 electrons? That means it lost 3 valence electrons. So of course this is 3 plus. Why don't they draw the 3 plus in for you? Obviously because they want to trick you. Because if I write 3 plus, it's so obvious. So which kind of elements will form 3 plus? Only group 13. Group 13 elements have 3 valence electrons. They lose 3 valence electrons to form the 3 plus ion. Okay? Now, so once you figure out it's 3 plus, the next step, of course, is to figure out what is the original electronic configuration. Now it's 2-8. Originally, it must have been 2-8-3. 2-8-3 has 3 valence electrons. It has 3 shells. If it's 3 shells, it's period 3. Those of you who chose A, the 4 of you who chose A, that means either you didn't work out the element or you didn't know that number of shells is the period number. Either way, it means you got to revise ions again. Okay? Now, for those of you who chose B, this means you got confused and tricked by the 2-8. So again, the first step is always to identify the element based on the proton number. All right? Now, for the 5 of you who chose C, great, well done. Okay, we're going to do the next one. Question 4. So we're going to do the exact same thing. All right? Question 4. Again, I'm going to A, B, C, D. Give me a minute. Let me set up the poll. Now, let me launch this poll now. Okay, so question 4 should be live. Okay, so let's start doing question 4. Okay, great. I think all of us have voted. So again, I'll show everyone the results. And the answer for question 4 is actually A. Now, the mass of an atom is almost entirely due to its nucleus because nucleus contains protons and neutrons. Now, protons and neutrons contribute the most mass because the mass of an electron is 1 over 1840. So the relative mass of an electron is so small, it's so negligible. Therefore, it is correct to say that the mass of an atom is almost entirely due to its nucleus. Now, another way to phrase this, the nucleus is the densest part of the atom. Okay, so the densest part of the atom is the nucleus. Okay, now how is density related to mass? So you learned in Sec 1, the formula for density is density equals to mass over volume. Since the mass is concentrated mostly in the nucleus, it is also correct to say that density of an atom, it is actually mostly in the nucleus. The nucleus is the densest part of the atom. Now, for those who chose C, you probably got confused because of the opposite charges. Protons have a charge of +1, neutrons have 0 charge. +1 and 0 are not considered opposites. Opposite charges means positive and negative. So the protons and neutrons are not considered opposite in charge. Opposite means one positive, one negative. +1 and 0 is not considered opposite. Okay, so for those 2 of you who chose C, you probably got confused by that. Okay, so protons and neutrons do not have opposite charges. Protons and electrons have opposite charges. Okay, so it's the protons and electrons which have opposite charges. Okay, so this is question 4 of the atomic structure MCQ. Okay, now after doing the 3 MCQs, you realize we love to test you on ions. We also love to test you on statements, sentences to describe atoms. So these are typical MCQs. The ions one is a useful trick. Okay, so if you were tricked by the previous 2 questions on ions, all the more you must be careful. You know that your ions not very strong, you revise ions. If you were tricked by this question, which most of you were not, that means your knowledge about how to describe an atom is good. Okay, now let's do question 5. The next one is question 5. Now question 5 is pretty hard in my opinion. All right, but you can try question 5. Hard is good, by the way. Okay, so anything that's difficult is great. Okay, so now let me do question 5. Okay, so now question 5 is live. Please answer question 5. You can see question 5 on your screen as well. Okay, I'm waiting for 5 more of you to vote, or 6 more of you to vote. Okay, 4 more of you have not voted yet. Okay, 3 more. Okay, everyone must vote, ah. Okay, 1 more person to vote. Then we'll show everyone the results. Okay, so maybe let's show the results now. So it's what A, B, C, D all got. That means this question is good, okay? From a setting perspective, this question is fantastic. Now, question 5 is difficult. Okay, so when it came out in 2019, I wasn't teaching pure chem in that year, but I was one of the teachers who was helping the pure chem students towards the end. This is hard, but it can be made easier. Okay. Now, again, you need to know the trick. What's the trick? The trick, of course, is this question is about isotopes, proton number, nucleon numbers. Therefore, you must help yourself. You need to start counting. So let's work on 3216Q first. We should count what? Count the protons, electrons, and neutrons. I'm sure you can immediately come to this conclusion, right? So 3216 means 16 proton, 16 electron also, because it's an atom. There's no charge overall. Finally, 16 neutron, 32 minus 16. Now, we're going to work out what is the new one. Proton, electron, neutron. So use the information to help us. First, it has 4 more neutron. 4 more neutron means 20 neutron. 16 plus 4 equals 20. It has 1 more proton, meaning 16 plus 1 equals 17. 1 more electron, 16 plus 1, 17. So it's 17, 17, 20. So R, firstly, does it have a charge? If it's 17 proton and 17 electron, proton equals electron. It's an atom. Atoms don't have charge. So anything with charge is wrong. So A and C are wrong. There's no charge. Okay? Next step. There's 17 protons. So it's 17 proton number. Then what is the nucleon number? 17 plus 20. P plus N is the nucleon number. So 17 plus 20 gives you 37. And hence the answer is D for question 5. So how do you do this such a question? Such a question, the technique is to write and count out the PEN. Now, the pure chem MCQ, if you have no working for the question, no annotations for the question, that means you are getting it wrong. All right. Now, from experience, so usually when I set the papers for pure chem MCQ, the teacher vetting the paper has full of working. Can you imagine the chem teacher makes so much working next to my question? That is the way to do pure chem MCQ. You must have annotations like Mr. So. All right. Can so that's question 5. Now at this juncture, we have done 4 MCQs already. any question before we move on to the last MCQ that we're going to go through for this? You could ask your questions in the chat or the Q&A. Nope. Okay, with that, let's go to the last MCQ for this particular set or the atomic structure. Let's go to set number 9. Question number 9, sorry. Question number 9. Okay, let me set up the poll. In the meantime, you can look at question number 9 and work out what your answer will be. Okay, now let me launch the poll. Okay, question 9. You might have to scroll down, I guess, to find question 9. Okay, in the poll. But let's vote. See, some of you are very fast. This is not Kahoot, okay? You don't have to play so fast. Okay, you should think through the question. Okay, 4 more students to vote for question 9. Okay, waiting for 1 student left to vote. Great. Now let's show the answer. Okay, show everyone the result, sorry. So the majority chose B. Okay, great. Because the answer is B. Now, again, you're going to be really, really careful. Highlight. It's M3 plus, guys. It's a 3 plus charge. If it's 3 plus means it lost 3 valence electron. Right? 3 plus charge means you lose 3 electron, meaning you have 3 less electrons than protons. Alright? Now, the nucleus contains 27 particles. 13 of the particles have a charge. May I know what is in the nucleus that has a charge? It's protons in the nucleus. This means, in other words, 13 protons. This thing has 13 protons, which of course is aluminium. It's the same aluminium as before, right? Aluminium has 13 protons. So this is actually Al3 plus. Therefore, it has 13 protons, and because it's 3 plus charge, it lost 3 electrons. So it has 3 less electrons than protons. So 13 minus 3 equals 10. So the answer is B. So again, I chose this question to show you how many times has ions come out already as a tricky question. If you keep getting tricked by the ions, you should revise ions. That's what you learn from TYS. In fact, you can see question 10 is about ions again. Almost every single year is about ions. What else could we test you on? Ions, isotopes. Just now we had isotopes. And finally, sentences to describe atomic structure. So that is what you need to learn from the TYS. Don't just do and calculate marks. Calculate marks is the most waste time venture. So what if you got 7 out of 10? Means nothing. The true A1 student will be able to tell me what questions are common for atomic structure. Ions, isotopes, and sentences to describe atomic structure. These are the common questions. And all 3 are obviously coming out. Alright? So you need to know it. Now, finally, let's move to structured questions. We're going to do the first structured question. 1A is an example of a deceptively simple question. Now, it's deceptively simple because most students think it's very easy, but they will lose marks here and there. Why? You need to read the question carefully. Now, they're asking about helium and argon, right? So they want to complete the diagrams of helium and argon to show the names and numbers of each particle in the nucleus. Hello? It's the nucleus. Many students did this. Some students wrote, helium nucleus contains protons, electrons, and neutrons, because they memorized. They memorized that atoms have protons, electrons, and neutrons. Wrong. Number one, are electrons in the nucleus? The answer is no, right? Electrons are in the shells. They're not in the nucleus. So this is already a wrong statement to write. Next, some students were like, never mind lah. Let's just don't write electron, no. Protons and neutrons. Still wrong. It's still wrong because you're lacking the number. You need not just the name, you need the number. Helium nucleus contains 2 protons and 2 neutrons. Because you know that helium is this. You go to the periodic table, you search for helium. It's 4-2. 4-2 means 2 protons and 2 neutron. How do you get 2 neutron? 4 minus 2. Many students still wrote 4 neutrons. I have no idea why. Alright? Please be careful. Neutron is the bigger minus the smaller number. Okay, now this is still not the full marks yet. Alright? You need to complete it for argon as well. So again, how do you do argon? You go to the periodic table, you search. Argon is 40, 18. So what is inside argon's nucleus? There are 18 protons. And is it 40 neutrons? Please be careful. It's not 40 neutrons, it's 40 minus 18. 40 minus 18 is 22 neutrons. This 2 boxes correct is 1 mark. And in 2018, most students finished here. They thought they finished the question. Because I have finished the dotted lines, what? It's finished, it's done. I've done the dotted lines. Is it correct? Is this the full mark? Is this all they wanted from the student? Now, the trick is every single time there's a bullet point in the question, always tick after you have finished the bullet point. I have finished the names and numbers of particles in the nucleus, but have I finished all the bullet points? The answer is no. I have yet to finish the arrangement of the electrons. The second bullet point is not done. You now need to finish the arrangement of the electrons, which I'm sure in 2018, if students had seen that, they would have done it correctly. Because this is ultra simple for most students. But because most students didn't see the second bullet point, they ended up losing that mark. So please, you need to read the bullet points carefully. Now we're going to do 1B. Now 1B obviously is from the chapter on periodic table, but we have not done periodic table. Really? Have we really not done 1B? Use your diagrams to explain how and why helium are chemically similar. You have already learned this under atomic structure. They are chemically similar in what way? They are chemically similar in the sense that both of them have fully filled outermost electron shells. We have learned this. You have used this so many times. Okay? And you should know and recognize that both of them are noble gases, meaning they have fully filled outermost electron shells. But please don't stop here. It's 2 marks. You need to elaborate. So how does the outermost shell being fully filled make a difference? It makes a difference because if it's a fully filled outermost shell, they will not lose, gain, or share valence electrons. with other elements. So most students do not elaborate and they will lose the mark. The impact is that they don't lose, gain, or share valence electrons with other elements. So, hence, they are unreactive, or you can say inert. So noble gases like helium and argon are inert, unreactive because of this. Now, this is a A1 plus answer. Okay, this is very complete. It addresses why, it addresses how. So this is the how and why. You see the question is phrased as such, right? The how and why. Okay. Now, we have gone through this structured question. The next structured question, Mrs. So will get you started. I want you to try it on your own as homework if you have not already finished the next question. Now, the next question is hard. It was the first question of 2023 Pure Chem. All right, it's harder. Now, firstly, it's not group 7, it's group 17. This is group 1. All right. Now, how do you get started? After much screaming and nagging from Mr. So, the 2023 students finally knew, please identify the element. Now, if it's group 17, period 2, go to the periodic table and find. Group 17 and period 2 is fluorine. If you know it's fluorine, you probably will be able to work out faster. Okay? Now, for element Y, it is group 1. Group 1, the ion is only like that. Only got 2 electron. That means originally, this atom had lost 1 electron, become like that, right? So originally, the atom is 2, 1. So this is actually lithium. All right. Finally, the next one is period 4. All right. The ions look like this. Okay, so which element is this? Okay, so this should be tellurium, I believe. If I look at my periodic table, sorry, not tellurium, blah, blah, blah. Selenium, sorry, selenium. Now, if you didn't get this correct, if you couldn't identify the elements, please ask Mr. So. All right, now this is difficult, but yet, all right, all my students could do it. All right, after much practice and much screaming from me, for probably to identify the element. Now, most students didn't do well in 2023. 2023 was a difficult paper for students, but my students, 2/3 of them got AYA2. All right. The reason is because I always teach my students, please identify the element's name where you can identify the element. All right. So if you cannot identify these 3 elements, please reach out to me. Okay. Now with that, you should probably be able to complete the table. You should probably be able to do B and C. You can't do D because you have not learned this chapter on periodic table. This one is not tested for the end of year, part D. But part A, B, C, you should be able to do it by now. Okay. Now let's go to topic number 3, which is on bonding. Again, we're not going to go through every question. We're going to go through some questions only. All right. So let's go to topic 3. Okay. So once you have topic 3, can you give me a thumbs up or something? And yes, we're going to start with question 1. All right, the MCQs as a warm up only. Okay, so I'm going to launch question 1 now. So topic 3, question number 1. It's a warm up, but still you need to read carefully, okay? So far 8 people have voted. How about the 3 more people? Okay, 9 people have voted. Okay, one more person, please. Okay, great. Most of you got it. Okay, the answer is B. But as a revision, let's go through once more. Diamond has what kind of structure? The name of the structure is giant molecular lattice. Now, giant molecular lattice structures like diamond, graphite, silicon dioxide, these three are your common giant molecular lattices. The giant molecular lattice substances will have the highest of the highest. Even if you compare them to ionic compounds, generally giant molecular should be the higher melting point. Okay, so the highest melting point should belong to the giant molecular lattice structures. So diamond must be the highest. Once you know diamond is the highest melting point, the answer left is B lah. Okay, but let's go through chlorine and bromine. Now, chlorine and bromine, you should know by now, chlorine is not Cl. Chlorine exists as diatomic molecules, Cl2. Bromine also, Br2. You have done this in electrolysis a lot, right? So chlorine is Cl2, bromine, Br2. Now, chlorine is a greenish yellow or yellowish green gas. Bromine is a liquid which dissolves in water. So you can already tell chlorine is a gas, bromine is a liquid, meaning chlorine has a lower melting and boiling point than bromine, just based on the state. Finally, sodium is a solid, all right? Even though sodium doesn't have a high melting point, it's still higher than bromine because sodium is a solid at room temperature. Now, sodium obviously is a metal, so sodium has a giant metallic lattice structure. Okay, so sodium has a giant metallic lattice structure with strong electrostatic forces of attraction between the delocalized electrons and the positive ion of sodium. Okay, now if you have forgotten the structures, don't continue doing the TYS. Go read through chemical bonding. Now, for any school in Singapore, chemical bonding must make up a lot of marks for the 3E end of year. Because the 3E, you have only learned a few chapters, chemical bonding being one of the most significant ones in terms of content, in terms of coverage of learning outcomes, in terms of depth of application. So chemical bonding is non-negotiable. You must revise. All of them. Everything is coming out. Okay? A lot of marks. Now, that's question number 1. Now, let's go to question number 3. So if you can just turn to question number 3, again, I'm going to set up the poll. Q3, A, B, C, D. Okay, so now let's launch the poll for Q3. In which compound does one of the atoms not achieve the electronic configuration 2,8? Okay, question 3. It's a rather split vote. Waiting for 2 more students to vote. If you recall, I've given you 2022 WA1 to practice. This is one of the questions. All right. So now let me show you the results. And the answer is A. The majority of you got it correct. Now it's very easy to work it out. Chlorine itself is 287. Now, after bonding, it wants to achieve 288, the fully filled outermost shell. So chlorine cannot have electronic configuration 28. Therefore, the answer is A, CCl4. All right. The rest of the substances, if you look at magnesium, this is Mg2 plus, is 28. This is Na plus, is also 28. Because magnesium loses 2 valence electrons to form Mg2 plus, so it's 28. Sodium loses 1 valence electron to form Na plus, also 28. All right. So the answer is A. Chlorine doesn't have the electronic configuration 28. It can't have. Okay. So if you don't know how to do this, you need to revise the whole of bonding. That means your concept of achieving a fully filled outermost shell is not strong. So you need to read through the concept of ions and also covalent bonding once more. Firm up your concept of what it means to achieve a fully filled outermost shell. When I was your age or even younger than you, when I was in Sec 1, I took the periodic table. I literally wrote out one by one. Sodium 281 loses 1 valence electron to form Na plus 28 with a fully filled outermost electron shell. Magnesium 282 loses 2 valence electrons to form Mg2 plus with a fully filled outermost electron shell. All the way until chlorine. Chlorine 287 gains 1 valence electron to form Cl minus ion with a fully filled outermost electron shell. In addition, chlorine can also share 1 valence electron to form a molecule with a fully filled outermost electron shell. So obviously CCl4, carbon is a non-metal, chlorine is a non-metal. So CCl4 is not ionic, CCl4 is simple molecular. So it's about sharing of valence electrons. So it is also important when you write non-metals to figure out, besides gaining electrons, non-metals can also share electrons. So chlorine shares 1 electron with carbon so that it achieves a fully filled outermost electron shell in the molecule. So that's good practice, taking the periodic table, going through all the elements, the first 20 elements, and figuring out, do they lose, do they gain, or do they share valence electrons? Okay, so that's good practice. That is revision, not just reading blindly and memorizing. Okay, in fact, by now, if you close your eyes, you should actually know where the elements are in the periodic table. If you need to look at the periodic table to find sodium or find chlorine, that means you have not been revising enough. I'm sorry. All right, we actually need to revise so that you know where sodium is, you know where chlorine is. Okay, now we're going to go to question 4. So let's start. Question 4. Which particles are responsible for the conduction of electricity through metals? Let's start. Okay, very good. People are like thinking, I hope. Reading, I hope. Okay, 2 more students to vote. Okay, so you realize we also covered this under electrolysis recently. If you go back to concept number 1, okay, in electrolysis, the current chapter, we actually went through this, right? Yeah, and the answer is A. Now they are asking you which particles are responsible for conducting electricity through metals. So they're asking you which particles can move freely. Because you know It must be a charged particle that moves freely to conduct electricity. So another way of asking this question is which particles can move freely in a metal? And the answer is the delocalized electrons. The positive metal ions cannot move freely because they are in the metallic lattice. They only vibrate about fixed positions in the metallic lattice. So the electrons, the delocalized electrons, are the ones that move freely, not the positive ions. The positive ions cannot move freely. They are in the metallic lattice in fixed positions. Okay, so if you wrote B, three of you wrote B, that means you have a misconception. You need to revise metallic bonding, which is in chapter 4, part 3, as well as electrochemistry, chapter 13, concept number 1. Okay, I can even tell you which chapter, which part, which concept. I think you should get to that level. Okay, so if you chose B, please revise metallic bonding and electrochemistry. Now let's move on. Next page. Let's go to question 6. We're going to do question 6 now. Okay. Again, we're going to vote. Okay, so I hope you realize by now MCQs are actually quite hard. They are not as easy as it looks. Having said that, you can make it easier by having good concept. So now let's go to question 6. Let's vote now. Covalent bonds are formed when atoms share electrons. How many electrons are provided by each of the atoms of the following elements? Obviously, this is testing you on your concept of covalent bonding. Okay, one more student to vote. Okay, great. So A, B, and D, with the majority, vast majority, choosing D. Very good. And the answer is D. Now, again, this is about covalent bonding. If you got this wrong, this means your concept of covalent bonding is not strong. So revise chapter 4, part 2, covalent bonding. Now, how do you work this out? You work this out based on the fact that oxygen is in group 16. It has 6 valence electrons. So if oxygen has 6 valence electrons, it needs 2 more. So it shares 2 electrons. You do the same for fluorine. Fluorine is group 17, 7 valence electrons. So it needs 1 more, so it shares 1 valence electron. Carbon is group 14, 4 valence electrons. It shares 4 electrons. Therefore, the answer is D, 2, 1, and 4. Okay, if you chose A and B, that means you need to revise. Okay, now this need not be tested like this. I'm going to show you another way of testing question 6, which you now need to copy down. Okay, there should be some space on your own TYS. Okay, so are we ready for that? Now, I believe I've done this with you in class. One good way of testing you is to do this. So can you please draw out this molecule? Now, this is a molecule called pyrrole. Now, I want you to work out, may I know which group is X found in? Is it group what? Okay, and to help you, I'm going to create a poll. Okay, Okay, I've launched a poll. It's an MCQ. X is from group number what? Okay, I hope by now you can see your misconceptions coming out. Some of you have a lot of misconceptions. That's why you got to clear it up. Don't assume you know. All right. Of course, if you are consistently getting it correct, that's good. Now, this is related to question 6. So when you revise, also revise this with question 6. Especially if you got this X wrong, you need to revise. That means your concept is not very clear. Okay, and the answer. Let's end the poll and show everyone the results. X is from group number 15. Now, how do you work this out? The way to work this out is to look at how many bonds are around X. Just ignore the carbons already. Just look at the X. You just want to focus on X, right? I'm asking you about X, you focus on X. X has 3 bonds around itself. If it has 3 bonds, it means there are 3 pairs of electrons shared, right? You share one, I share one, we make a pair, right? That means X shared 3 electrons with the other atoms around itself. If X shared 3 electrons means X originally had 5 valence electrons. That's the idea. Because X having 5 valence electrons, it needs 3 more electrons. If you need 3 more electrons, you share 3 electrons. So the answer is 15. Okay, now some of you chose group 13. Now, if it's group 13, the molecule will not be stable. Because if it's group 13, it will have 3 bonds, but it will be electron deficient. Okay? Now, so it's not group 13, it's group 15. Okay? So this is called pyrrole. Now, pyrrole actually has nitrogen. So the X is actually nitrogen. Alright? The X is nitrogen in the case of pyrrole. Now, another molecule that looks like this is furan. Furan looks like this. You can copy down as well. These are commonly tested molecules we love to test. Now, furan looks like this. You notice furan has an oxygen instead of a nitrogen. And you notice that the oxygen has no hydrogen on it because oxygen is group 16. Group 16, 6 valence electrons, it needs 2 more. So you share 2 electrons, forms 2 bonds only. So oxygen is done. 2 bonds is done. No more. Okay? So furan, the oxygen only has 2 bonds with the carbons. It has no hydrogen attached to it. Whereas pyrrole with nitrogen, N is from group 15, therefore it shares 3 electrons. Therefore, it forms 3 bonds. That's why there's a hydrogen attached to it. Okay? So that's furan and pyrrole. Okay? Now let's move to question number 7. Question 7 is my classic, my favorite. All right? I can ask this every single year and students will still get this wrong, even at the prelim stage. Okay, so let's launch the poll for question number 7 about oxygen crystals, freezing oxygen at negative 223 degrees Celsius. What will the oxygen crystals contain? One more student to vote. Okay, I'm just going to end the poll here and I'll show everyone the results. You can see it's a very split vote, right? Yes. The first step is to know what on earth is oxygen. Oxygen is O2. I hope we know that. It's diatomic. This has a simple molecular structure. If it has a simple molecular structure means it consists of molecules, 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 which are held together by weak intermolecular forces of attraction. Meaning, the answer cannot be ions. The answer cannot be atoms either. Okay? When you say oxygen atoms, it means there's O present. It's the oxygen atom is not bound to anything, it's not bonded to anything. So those of you who chose A and D, I guess you thought that there were atoms. No, there's no atoms. The atoms have already covalently bonded with each other by sharing electrons to form molecules. So the answer is C. It's not A, not B, not D. So what has atoms? What can contain atoms? There are only two things that can contain atoms in the structure. Atoms are only present if it's giant molecular. So like diamond. Diamond consists of carbon atoms. Silicon dioxide consists of silicon and oxygen atoms. Graphite, carbon atoms. So if it's giant molecular, then you can have atoms present. That's the first possibility. The next possibility for atoms to be present is if it doesn't share electrons. So noble gases, group 18, they do not share valence electrons because they already have a fully filled outermost electron shell. So group 18 noble gases will exist as atoms. So the answer cannot be oxygen. Oxygen has to have molecules, O2, because it's simple molecular. Even as a solid, crystal, it consists of oxygen molecules. That's why I say question number 7 is very good. A question. Okay. Now we're going to fast forward to question 13. Okay, question 13, question 1, 3. All right, again, I'm going to create a poll and then we can vote together. Question 13. A, B, C, D. Okay, let's go. Question 13. Okay, one more vote. Okay, great, we're done. End the poll. Now, the trick to doing this, of course, you realize it's about mole, mole. To figure out the mole or mole, you need the mole ratio. To get the mole ratio, you're going to need some formula first. You need the chemical formula. You should write the chemical formula out. Again, like I said, if you do not have working, it's wrong. Even if you got the answer correct, you got it correct by luck. You need to write the formula out first. Okay? Now, what's the purpose of writing the formula out? The purpose of writing the formula out is to show you what's the mole ratio involved. What do I mean? So let's take the first one, Al2O3. If I have 1 mole of Al2O3, it has how many mole of Al3 plus? How many mole of O2 minus? Let's try to answer that. 1 mole of Al2O3 has how many moles of Al3 plus? I think it's quite obvious. 1 Al2O3 should have 2 moles of Al3 plus. How many moles of O2 minus? 3. That is the meaning of Al2O3, right? How is this relevant? Now let's relate this to electrons. We know Al3 plus has to lose electron. Okay? Al3 plus means it has lost 3 electrons. But I have 2 Al3 plus, If I have 2 Al3 plus, that means it lost 2 times 3. 6 moles of electron. It must mean that each Al3 plus lost 3 electrons previously to form Al3 plus. I have 2 Al3 pluses. That means it lost 6 moles in total. Obviously, this means that it gained 6 moles of electrons. So clearly, how many electrons are transferred? 6 mole. Therefore, the answer is A. Some of you chose D. So let's work it out. Sodium oxide, 1 mole of Na2O has 2 moles of Na plus, 1 mole of O2 minus. Sodium loses 1 electron, but there are 2 sodiums. So in total, they lost 2 moles of electrons. Oxygen, to form O2 minus, must have gained 2 moles of electrons. So Na2O did transfer 2 moles of electrons in total. Now this, ladies and gentlemen, is the level of working that I expect for all Pure Chem MCQ from start till the end. Question 1 to 40 looks like this. Alright, now it's not stressful, don't worry. But what you need to train yourself to do now is to do working. Every MCQ has working. If you wrote the formula out, good for you. Even if you got it wrong, at least you wrote the formula out. You already got the first step. But if you work this out without even writing a single formula out, you just thought in your head, it won't work. Your MCQ mark will forever be stuck at 25, 26 out of 40. In order to improve towards 35, 36, which you need, okay, you will need to write working like this. I hope I made it clear. All right, that's question number 13. Okay, any questions you can ask in the Q&A. I'll try to answer you. No. Okay, are we good to continue? If you are good to continue, can you please let me know? We'll do one last MCQ for today. All right, then we'll move to one of the structured questions and then we'll end there. Okay. Okay, so are we good to continue from here? Just let me know. Okay. Now, if you got this one wrong, you will need to revise formula writing, of course. But beyond that, I think you need to revise your technique in doing MCQ. Did you write working like Mr. So? Even till today, I write working like this. Now, this is an important skill if you are moving on to A level. A level H2 Chem, every MCQ is like this. you must do working. There's no MCQ in A-level chemistry where it's just direct recall, straight off one step thinking. Most MCQs require 2 to 4 steps of thinking. Okay, now let's move to question 22. Okay, and we are now going to launch this poll, question 22, about copper metal. All right, so please start. Okay, are we okay? Do you see the poll? Yes. Hmm. So those who did it so quickly, fastest fingers first, may not have been very accurate. Read the four statements carefully. Examine every single word, dissect, tear it apart. Okay, one more to go. Okay, great. Let's end the poll and show everyone the results. Of course, the answer is D. Okay, of course, the answer is D. Only number 2 is correct. 1, 3, 4 are all wrong. There are different parts that are wrong. All right. Now, most of you probably thought 3 sounded correct. 3 is not correct. This part is wrong. Are the ions attracted to each other? You got to ask yourself that. Think about it. What is the ion formed by copper? This is Cu2 plus, you know. These are cation ions with a positive charge. Do positive ions attract each other? Does Cu2 plus attract Cu2 plus? So the idea is tear the words apart. Don't just fixate on attract. Yeah, there's attraction, but the attraction is between the ions and the delocalized electrons, not ion with ion. Okay? So the Cu2 plus does not attract Cu2 plus. The Cu2 plus attracts the delocalized electrons. So statement 3 is actually wrong. All right? Incorrect to say attraction for each other. All right, so that's question number 22. Now let's quickly move on to the structured questions. Okay, because I have another lesson after this, my Sec 2s. All right. Now we're going to do this, just this one part, 4A. Now, many of you are like, oh, how do we finish all the TYS? It is possible to finish, right? You have TYS questions already, know, for MCQ and 2 structured questions. All right. So now, can we look at question 4A, please? It's about CO2, carbon dioxide, and silicon dioxide. Why are their melting points different? How do you answer such questions? The first step is always to identify the structure. CO2 has a simple molecular structure. You must write this even though there are no marks for this. Because this anchors your thinking. Once you know it's simple molecular, you will know there are weak intermolecular forces of attraction between the molecules. You need to write between molecules, okay, which require little energy to overcome. Overcome is the word, not break. Hence, CO2 has a low melting point. Okay, so that's CO2. Simple molecular structure, weak intermolecular forces of attraction between molecules, little energy needed to overcome. Therefore, low melting point for CO2. Now we repeat the same, but for SiO2. SiO2 has a giant molecular lattice structure. So what are the forces? Strong covalent bonds between silicon and oxygen atoms. So just now we mentioned, right? Simple molecular is molecules. Giant molecular, we talk about the bonds between atoms, in this case Si and O atoms. Obviously, these are strong covalent bonds. They require a lot of energy to overcome. Hence, SiO2 has a high melting point. This is always the format of explaining physical properties like melting point, boiling point, electrical conductivity. You must write the name of the structures first to anchor your thinking. Then you realize part B, they wanted you to give a formula of one acidic oxide and one basic oxide from the table. So this is under chapter 8, acids and bases, where you learn the types of oxides. So this one you must know. Acidic oxide is formed by non-metals. Non-metals form acidic oxides, whereas basic oxides are formed by metals. So with that, there's a whole long list you could give. Acidic oxide, there's CO2, SiO2, NO2, P2O5, and SO2. Oxygen is not an oxide, so cannot. Oxygen doesn't count. Oxygen is an element. Oxide is a compound. So any one of the 5 over there is fine. Next one, basic oxide. Formed by metal, so you have lithium oxide, sodium oxide, magnesium oxide. Alright, now you notice I've deliberately left out beryllium, aluminium, and boron. Sadly, what you do not know, okay, what you should know, aluminum oxide is not acidic, it's not basic. Aluminum oxide is amphoteric. Amphoteric oxides react with both acids and bases. So zinc, aluminum, lead, they are amphoteric oxides. Now, actually beryllium oxide is also amphoteric. Boron trioxide, this one is a bit more vague. Boron trioxide can be amphoteric as well. Okay, but you don't know that. You don't know that. So, can you please choose formula which is more clear cut that you know? The ones that are very clear cut are like CO2 is acidic, that one you should know. NO2 is acidic, you should know that. SO2, acidic. Basic, choose obvious metal. Sodium is an obvious metal. Sodium oxide is basic. Okay, don't choose the ones that you have never learned before. Okay, or else you might have end up in trouble. Okay. So any questions so far? It's 11 o'clock. I need to start my next lesson, but any questions first that I can help to answer? Don't worry, I can still answer questions. Is everyone good? Have we copied down everything? If you have, can you give me a thumbs up? Now we will continue with bonding tomorrow and move on to redox and electrochem. So I would like you to do redox and electrochem, which is 7A and 7B. You should do it. The lesson will proceed like today. We will basically vote on MCQs like today and see your misconceptions. If you realize you had some misconceptions, can you please revise atomic structure and chem bonding? Not optional, very, very, very compulsory, very, very important and crucial to you doing well for the EYE. Okay? So with that, thank you very much. I'll see you tomorrow at the same time, 9:30. Okay, bye-bye.